Good morning, everyone. Can anybody let me know where we had ended the last class? I suppose we have completed numbers, data type, string data type, input and output, functions. What was the last thing we had done? Anyway, let me open up the okay, we have completed functions and input. Have we started control structures or control statements? If else. I just let me, okay, fine. Okay. Uh, okay. I suppose we need to now start. Continue from the control structures. That is for loop and while loop and other things. Okay. Let me just start sharing my screen. Is my screen available? Are you? Is it readable? Okay, fine. Okay. Now we will continue with the what do you call the next topic, that is loops. Earlier we had already seen how to write if condition, uh, if else statements, as well as elif. Elif in the sense else if. Else if is written as elif. And then we have also seen shorthand if conditions. But remember that there is no switch statement in Python. There is no switch statement in Python. If you have to implement the switch functionality, then you have to use the nested, or if you have to use the if else as well as elif statements. Now we will start with the control, the other part of the control structures, that is loops, or we also call it as iterative statements. Now here, iterative statements, you are going to have while loop as well as for loop, but we will not have do while loop. There is no do while loop in Python, as there is no switch statement in Python. The same way, we do not have do while loop in Python. That is, we don't have what do you call do and so while. So this thing is not there in Python. This part kind of a statement is not there in Python. But we have a while loop. So for a while loop, obviously the very first thing we need to have is we need to look at is the initialization statement. So what we will do is let us try to write the while loop to print five numbers. So we will start with I equal to, let's say, 1, and the next thing is while, let us say, I less than 5. Then obviously while is also is going to have its body, so we have to uh, I mean, there is no need to for the brackets here. We need to have a colon at the end of the while statement. So this is going to define the body of the while loop. So while I less than 5, let us say print I, and then the next statement we need to have is some statement where we can modify the value of the counter. So I equal to I plus 1, and then let us just run this program and look at the output. You can find that I has been printed 4 times because we had the condition I less than 5. So while loop works the same way as in any other programming language. That is, we need to have an initialization condition for the counter, and then we need to have a condition statement. Some condition, and obviously followed by not the curly brackets, but followed by a colon, and then indented body. So this part defines the intended body. So all the intended statements are part of the body of the while loop. So this is how while is going to work. Now remember that the conditions, the if statement or if else statements or if elif statements, all these statements as well as the while loop consist of a condition. Here we can have different what do you call conditions. All 6 relational operators work. That is what do you call the less than, greater than, less than, equal to, greater than, not equal to, as well as equal to relational operators work as part of the condition. Not only this, we can have expressions also, or we can have compound conditions, that is using some of the logical operators as and, or not. So but in Python we have to use and as the word there as a keyword. We cannot use ampersand for writing the and condition. So for example, if I have something as I greater than let's say 3, and I have to do, I cannot write it this way, and I less than, let's say, 10. So I cannot have the condition this way, a compound statement, and this and will not work. I have to specifically use and word itself. So this is your logical operator which we need to use. So you can have compound conditions. For or, we cannot have this way, it will give us an error. For or, pipe symbol is not used, but the word or itself is used. Same way for not. So this is how we can have compound statements in Python. Now moving further with the other loops, that is the for loop, let us consider. For loop is not like any other for loop we have in other programming languages. Like for, suppose we have for, let's say, I equal to 0, I less than 10, and then I equal to I plus 1. We don't have this way. In Python, for loop is very much simpler. For loop, actually, the format of the for loop is it will take for some variable, let's say var in, and it will have sequence. It will have sequence here. So for in sequence, and followed by colon, and then rest of the statements we are going to have. Now this for var any variable or object, that is will work as your for I. equal to 0 or I part. In sequence means here you should have some range, or you should use some sequence of numbers or sequence of objects or sequence of what do we call a list, tuple, or something. So it should be a sequence. It's like an how we use the array in other programming languages, same way we need to have, use a sequence there. So before we look at the for loop, let us try to talk about some what do you call a function which creates a sequence. Now Python provides a function known as range. Range. Now this range function will consist actually can take in one argument, or it can take in two arguments, or it can also take in three arguments. A range function with one argument. For example, if I give as range of 5, if I pass a range of 5, it will give me numbers from starting from 0 but 5 but 1. So from 0 till 4. Suppose if I give two arguments, that is let's say 3 comma let's say 10. If I have a range 3 comma 10, will give me numbers series or sequence of numbers starting from 3 till 9. So 10 minus 1. So last but 1. So 3 till 9. Now what we can do is, let us try to print this. Let us try to print the range. Now when we print range, it only says there is a range function and all. It will not give us what are the values inside that. But the values is that if only one argument is passed, that means the range will start from 0 till that argument minus 1. Now if there are two arguments, the first argument is the starting of the sequence and the second argument is ending but 1. So n minus 1, end but 1. We can also have three arguments. So let us talk about three arguments, the third argument later. What we will do is we will try to create a for loop for, let's say, I in range. Range of what? Let us say 5. Because we will be using the same, what do you call, the last time how while loop we used to print numbers till 5, the same way we will use for I in range 5, because range 5 is going to give us 0 to 4. So let us now try to print the values within I. Let us execute this program first. So once we execute it, you can find that it starts from 0 till 4. Now here what is happening is the for loop. When we say for I in range, that means each time the for loop executes, I will be retrieving a sequence, that is the values of the sequence. So for the first time, I will be retrieving the first value from the sequence. Here the sequence is range. Now the next time, the second time the for loop runs, I will be retrieving the second value. The same way, third value, fourth value, till the values, till the last value or the element in the sequence. So here range created sequence from 0 to 4. So that is why starting from 0 till the last element in the sequence, that is 5, that is 5 minus 1, which is 4, has been retrieved. Now suppose if I have to create say some generate numbers between some range, between a range. So I can use, for example, starting from 3 and then ending at, let's say, 7. So what will happen is this range function is going to create a sequence starting with 3 till 6. So when we execute this program, we can find that we have 3, 4, 5, and 6. 6 because we have the last as 7, 7 but 1, that is 6. 7 minus 1, that is 6. So this is how the range is created. Now, let us try to use the third argument. Now what I will do is I will start the range from 1 till, let us say, 10. And when we print 1 till 10, we're going to have all what do you call 9 actually I'll just have this toolbar moved this way. Uh, okay, this is much better. It will be easy for us to look at what is happening here. So the range is now 1 till 9. Now the third argument is the step. Now what is happening if we are using two arguments is that each time the second element which is generated or created in the range or in the sequence, it is incremented by 1. So if you start from 1 till 10, it will be the next the start with 1, the next will be 2, 3, 4. Suppose if you start with 3 to, let's say, 7, it will start from 3, the next will be 4, 5, 6. The third argument is actually a step. So till now what we were doing is we were having the incrementing part as I plus plus, or I equal to I plus 1. Now the third one is a step where we can change the what do you call step of increment for the range. For example, suppose I take the step as 2. So what will happen now? A range of numbers or sequence of numbers will be generated from 1 till 10. Then starting from 1, 1 will be the first element. The second element will be incremented by step of 2. That is, so second element will be 1 plus 2, that will be 3. Third element will be 3 plus 2, that will be 5. So this way till n, but not n. That is till 10, but not 10. Now here I am not telling 10 n minus 1 or but 1, because we don't know what the step would be. So it will be the second argument but 1. So let us now execute this program. You may find that each element is increased with a step of 2. The same way, suppose if I do step of 3, you can find that each element is incremented by step of 3. Now what is happening at the last is, this is the third element, 7. 7 plus 3 will be 10. But since it should be, the second argument is 10 and it should be second argument but 1, the range should be less than the second argument but 1. So that is why we are stopping at 3. The third element, that is 7. Now not only the step can be an incrementing step can also be a decrementing step. For example, we can also have minus 1. Let us if we execute this, nothing will happen. If we execute this, nothing will happen. Now we have the step as minus 1, nothing is happening, nothing is getting displayed. Why? Because start is there, start with 1, then minus 1 will be 0. So it does not make any sense. So what happens is, when you use negative steps, or when you try to decrement it, the first argument should be greater than the second argument. So now we can have, suppose if you have to print the numbers in reverse order, so like 10 till 1 in increment by minus 1, you can find that we have starting from 10, each time we are decrementing a value because step is minus 1, and we are having till the sequence till 2. This is because the next 2 minus 1 will be 1, but 1 is the second argument and the value should be less than the second argument. So 1 is not displayed here. So that is the what do you call, this way we will be able to create the sequences reverse order also by using the negative indexes. Not only minus 1, we can also have minus 3 or minus 2, which works the same way. Each time it will be decremented by in this case it is decremented by by 3. So this is how the range function will be helpful with respect to the for loop. Now why I said this part as sequence, because It may not be always a range. Range is just a sequence. Now this for loop can be very conveniently used with lists, tuples, and dictionaries as well, so that we will be able to access their elements. So those are also sequences. So here, just for the demonstration purpose, we have used a range function. But apart from range function, we can also apply this for loop very conveniently with the other data objects in Python, that is lists, tuples, sets, and what we have is the dictionaries there. So this is how for loop will be working. Now, before we close this, a part of the, the condition statements and iterative statements, remember that we have assignment operators like in Python. We have seen already the arithmetic operators and double slash or integer division operator, relational operators also we have seen. Let us, before we move on to the other part of Python, let us see some of the assignment operators. Now, I have been writing this I equal to I plus 1. Now, let us define I equal to, let's say, 10 itself. Now, we are using I equal to I plus 1. Now, I can also write I plus equal to 1. Shorthand assignment operator that we have seen in C and Java. The same way here also, we can use assignment operator as plus equal to. We can use minus equal to. If we use minus equal to, it will be like I equal to I minus 1. This way. We can have I multiply multiplication also. So it will be I multiplied by I into 1, and divide, integer division, so and so, modulus, so and so other things. So we also have assignment operators here in Python. But remember, we don't have increment and decrement operator in Python. So I cannot use I plus plus. There is no increment or decrement operator in Python. I cannot use post, neither I can use I cannot use post increment or decrement operator, neither I can use post increment pre-increment and pre-decrement operators. So there is no as there is no switch statement in Python, there is no do while loop in Python. The same way there is no increment and decrement operators in Python. That is, there is no pre-increment as well as post-increment operators. Now, for the post-incremented, that is, if I have to use I equal to I plus plus, then I need to use I equal to I plus 1, or I can use I plus equal to 1. This way I will be able to use it. The same way, even decrement operator, I can use it the same way. But to have the functionality of decrement operator, I can use it the same way. But I cannot use I minus minus, or I cannot use I plus plus. There are no increment and decrement operators in Python. So remember this. Now, we are getting if I have I plus plus, I as well as I minus minus, this editor itself is showing me that there is an error at this place, at this statement. But when I am using plus plus I, that is pre-increment and pre-decrement, there is no error here. So straightforward, I plus plus or I minus minus will not work. Though I plus plus I, that is pre-increment I and pre-decrement I is, though these statements are valid in Python, but they do not mean that it is incrementing, pre-incrementing I and decrementing I, a variable. Doesn't mean that. though these are syntactically correct. What is happening here is, here we are having I, the value of I. So for the value of I, plus is used as a unary operator. So plus 10 is nothing but 10 itself. Then to that 10, again a plus is applied. So this is used as a unary operator here. So that is why it's not giving us any error. The same way, if I have minus minus I, there is no error. But the thing is, here, if it is 10, this will become minus 10, and then minus 10 of minus will become again plus 10. So though this, they will not have any, you will not get any errors here, but the the values are not correct. So there are no pre or post increment or decrement operators in Python. Just have this in mind. So next thing we will move on is writing files. Okay, no, not files. We will move on with the object that Python. There are several other objects which Python uses or has. These are list, tuples, sets, and set and dictionary. List, tuple, sets, and dictionaries. Now we can create list using the list method. It's actually a list class. Tuple using tuple class. Set using set class, as well as dictionary using dictionary class. That is the brackets. Or we can use the symbols or the characters that are used to denote respective objects. For example, the list is denoted using square brackets. Tuples are denoted using normal brackets, parentheses. And sets uses the curly brackets, as well as dictionaries also uses curly brackets. So these are the symbols or characters which are used to denote different data objects in Python. So list will be denoted using square brackets, tuples using parentheses, sets and dictionaries using curly brackets. Now let us look at each of them. List and tuples as well as dictionaries are ordered set of data. They are ordered set of data. Ordered set, or we can also say ordered collection of data. So all these three things, list, tuples, and dictionaries are ordered collection of sequences, or ordered collection of data, or ordered collection of elements. Now, why we are saying ordered collection means the number of elements the set has, the number of elements the list has, tuple or dictionary has, there is a certain sequence to it. So it will be ordered in some sequence. And we can access those elements using indexes, like we do it in arrays. Now, Python doesn't have any concept of array. There is no concept of array in Python. Though we can store or we can create arrays, or we can use methods and operations like arrays using list. Now the difference between these is tuple is immutable. Tuple is immutable. That means once a tuple is created, we cannot add any elements to it, or we cannot change the tuple. But whereas list, dictionaries, and sets are all immutable. That is, we will be able to, once a list is created, once a dictionary is created, once a set is created, we will be able to add values to it, or delete values or elements from it. So these three things are immutable. Now, that's list, tuples, or dictionaries and sets can contain elements of same type, as well as they can contain elements of different types. Of different types. Now, there is a function defined as length, len function, length. Now, this len function also worked for strings. The same len function works for lists, tuples, dictionaries, as well as sets. Now, this len function returns the length of the list, length of the tuple, or length of the dictionary, or length of the set. Length in the sense number of elements in all these four data objects. That is lists, tuples, dictionaries, and sets. Now, we had heard a lot of theory about. Okay, let us the other two things. That is, so the cases list and tuples are same, except that the list is immutable and tuples are lists are mutable, tuples are immutable. Tuples cannot be changed, but list can be changed. Now, whereas dictionaries will be consisting of elements of the type key value pair. It will consist of the element as name value or key value pair, what we call. And difference between list, tuples, and set is that sets are also immutable, uh, mutable, they can be changed. But the difference is that list and tuples may contain duplicate elements, whereas sets will not contain duplicate elements. Sets will only contain unique elements. So this is the difference and common things about what you call these four structures. So let us quickly look at these four structures. And the other thing is, for we would be able to use the square brackets. Obviously, square brackets is to use to create list, but square brackets we can use on any of the what you call these objects to retrieve their values. So indexing is possible. Uh, I mean, on what you call mm, list and tuples. Whereas for dictionaries, the indexing, we cannot pass the index there. We have to pass the key so that the value can be retrieved. So that is the other thing. And the other what do you call operators that can be used are the what do you call, there are special operators there in Python, uh, such as membership operators and identity operators. Now, these two operators are not present in the other programming languages. So as we move further, we will try to also look at the what you call membership operators as well as identity operators. Now, apart from that, we can also have slicing, which we have seen in what in the strings. For example, we had something known as s of uh, 2 colon 5, slicing operator. So this is also present in what you call, we will be able to apply slicing on the tuples as well as the list there. So let us now quickly look at what these things are. We will start with the tuple. So let's say T1 as the tuple name, T1, and tuples are created using what do you call parentheses within brackets. Tuples, we can directly create a tuple. So within parentheses, let us pass the value as 10, 20, 30. Let us create another tuple. We can also create a tuple as a string. So let's say A, comma, B as the tuple. Now let us print these tuples. Let's say T1 and print the tuple T2 as well. Now when we execute this program, you can see that the tuples are retrieved and they will be having what do you call the brackets or parentheses. Now we can use indexing to retrieve the values. For example, I want to retrieve the second value from the tuple T1. So I can use square brackets, and this square bracket doesn't mean it's a list. This is for accessing the elements. So I can use square brackets in pass 1, and when we run this, you can see that the second the element from the tuple T1 is retrieved. Obviously, remember that the indexing in Python starts from 0. So 0th is the first element, then the second element is 1, so on and so forth. Now suppose if I want to retrieve value, fifth value. So T1 of 5, suppose if I do, you can find that I'll get an index out of bound error, that is an exception or an error is raised. So we cannot access elements beyond the, we cannot use indexes beyond the number of elements in our list. Sorry, in this case tuple. So we can also have length, len function, length of T1 and length of T2. This will give us the number of elements in the tuple, that is T1 has 3 elements and T2 has 2 elements. Now apart from this, we have a membership operators, what I was talking about. These membership operators are nothing but in and not in operator. Not in operator. Now, in operator is actually membership. What membership operator does is, membership operator will try to find the element within the sequence. If it is found, that is in operator, if it is found, if the element is found, for example, uh, suppose x in a sequence T1. So if x element is found in T1, it will return as true, else it will return as false. And not in will work, not in membership operator will work exactly opposite to in membership operator. So let us now look at here. Suppose if I say 10 element in, let's say, T1. And the same thing if I say element 10 in another sequence, that is the tuple T2. When we run this program, the first one is giving true because the element 10 is present in, say, the tuple T1. It is there. There's an element 10. But whereas second statement give us false because element 10 is not present in the sequence T2. Only elements are A and B. So this is how the membership operator works. And obviously not in is exactly opposite to in membership operator. So what happens is, if I say not in 10, not in T2, it will return me true because 10 element is not present in T2. So that is true. Now there are identity operators also in Python, which is nothing but is and is not. The same way like in and not in. So in and not in are membership operator. That means the element is a member of that sequence or not. The same way is and not in will try to compare the value as well as the type of the element, type of the what do we say, um, type as well as the value of the two operands or two objects. So these are called as identity operators. Now, for example, if I have something known as x equal to, let's say, 10 and have y equal to, let me say, 7, and I will say print x is y. Now this will give me result as false. It's false because the value itself is not equal. So at this stage itself it is false. But suppose if I have 10.0. Now if you see, look at it, at these two things, the value, this will give me, if I run this also is going to give me false, because here what is happening is value 10 and 10.0 is also 10 mathematically. They both are same, but the type is different. Here the type of x is integer, and the type of y is a float. So therefore, even though the values are same, but the type is different, x is y is going to be, is operator is going to give us false. And obviously, is not will work the exactly opposite way to what do you call is operator. So if I have is not, I'll get the result as true. So y x is not y, it's not equal to y. But when we were using equal to, when we are using x is y, it compares the value as well as the type. Now suppose if I have print x equal to y. Now here what is happening? It will return as true. So the equal to operator, remember that only compares the values. If it is equal, then it is true. But whereas is operator computes values as well as it will compute the type. So in this case, if we have 10 and 10.0, it will be false. But suppose, okay, let us look at one more way. 10 and 10 as a string. Let us look at the answer. Here also, both are false because this is x is y is 10 is the value is fine, no problem. But the type is different. One is the integer, the other one is a string. X equal to y is also false because this is considered as a string 10, not a value 10, not a numeric 10. So that is why this is going to give us false. In both the cases, false. Now these operators can also be applied to tuples. For example, when we have T1 and T2, I can say T1 is T2. Now, when we run this program, it will give us the result as false. Now, assume that T2 had 10, 20. Even this is going to give us false. Why? Because there are 3 elements here. There are 2 elements here. Not 2 and 3. The thing is, the first value is same, the second value is same, but not the third value. There is no third value in T2, but there is a third value in T1. So that is why it's giving us false. But suppose if I have 30, T1 is also same, T2 is also same. Now I will get the result as true because every element, its value and type is same in what you call T1 as well as T2 tuples. And suppose if I have 20.0, and now I will have the value as false. Why? Because the first element is correct. The first element is same as type as well as value. Second element type is same, value is same, but type is different. It's integer and float. That is why now it gives the result as false. Not only that, let us look at this way: 10, 20, 30 as T1 and T2 as 30, 20 and 10. Now let us compare. Now also we are getting the value as false because every element is compared for its value and type with the is operator. And is not operator is exactly opposite to the is operator. So this is how we can perform the operations on tuples. Now tuples can also have a mixed type. For example, I can have 101 as the roll number, let's say A, B, C as the name, and third one as 78.25 as the what do you call marks, let us say. And this is not also not going to give us any error because tuples can have mixed type, same type elements as well as mixed type elements, as well as the mixed type elements. Now there is there is a method known as index and the other methods, like we can also perform the slicing on this on tuples. Now tuples doesn't have many more methods compared to the other objects because tuples are immutable, that is they cannot be changed once they are created. Now we will move on to the next one, that is list. Now these are what we are calling objects in Python. These are the objects, as well as sometimes they are also called as data structures in Python. So tuples, list, all these things are part of data structures in Python. Now let us create list as L1 as one list, L2 as another list. Now lists are created using square brackets. Lists are created using square brackets. Here we are we will be having here we will be using square brackets to create list. So L1 we can give any name, it doesn't matter, it's your variable name. L1 is there, which has 3 elements, and L1 is represented using square brackets. So square brackets are used for creating the list. Now when we display list, you can see that tuples were having in the display itself, tuples were having parentheses. Now list contains square brackets. So this is how list and tuples are identified by different ways of their display. Now list also has the what you call, we can access elements. Let us access the second list L2. List is list third element. So I have to pass 2 as the index, and this returns as the third element. So here also indexing in Python, all objects, the indexing starts from 0. So even for tuples, strings, as well as what do you call a list, all these things, indexing starts from 0. We can also have the length. What happened? Okay. We can also have the length function. So we can use len of let's say L2 or L1. We will get the length of the list. Now since and the other thing is list can also have use multiple other operators, such as membership operators as well as identity operators. So for example, if we say let us say 10 in not 10, let's say ABC in L2, it will return as true, because that the ABC is the element which is present in the list 2. Not in will work in the opposite, as well as the same way is and not, is not operators will work. Now apart from these operators, there are other methods available for the list class, because it is an immutable it is a mutable class. That means it can be changed. So it is a mutable class, so it can be changed. So we have several other methods available as part of the list. Now there is a method L1 dot append. Now this append method we will be able to use to add objects at the end, to add elements at the end of the list. So for example, if I have to add 40 to list L1, let us use print L1, and then after append we will also again use print L1. Let us execute this. So append operator basically adds the element to the end of the list. Now suppose if I have a list L1, and if I use append L2, now here you can find that what I'm trying to do, earlier I had 40 as a single atomic element there to be added. So my list was 10 comma 20 comma 30, but now I'm trying to append a list itself. So this entire list will be appended at the end. Obviously append is always done at the end. So this entire list will be appended where as the last element. So you can find 10, 20, 30. Then 101 ABC and 78.25 is not appended as individual elements. This whole thing is appended as a list itself. And how do you figure it out? You figure it out using the commas. So each element will be separated by a comma. So after this comma, you can find that a square bracket is opening. That means this is a list. So now a list is getting appended. So you can append a list as an element itself, or you can append individual elements. Now the other thing is, suppose I want to insert an element at, let us come back to 40 element. Now suppose if I have to append adds at the end, but suppose if I have to add somewhere after 10 at second position the element 40. So we can do that using using the index method. Sorry, not index, insert method. Insert, the first argument will be the position. Let's say position 1, comma 40. Second argument is the element itself. So when we run this program, you can find that at the second after 10, that is before 20, second position after 10, 40 is appended. So we will have 10, 40, 20 and 30. So append is used to add the element at the end of the list, and insert is used to add the element anywhere between within the position. Now suppose if I have, instead of 1, or if I say position let's say 2, so what will happen? So this is 0, 1 and 2, so it will be 10, 20, 40 and then 30. But suppose if I have a position as 8, the length of the list itself is 3 and I'm trying to insert at position 8, which doesn't make sense. But what happens is it will be added at the end, so it will not give us any error. So when we are passing 8 to insert at the position 8, when the elements of the list are 3, that is the position we have given for inserting is larger than the length of the list itself, then what this means is it will add at the end of the list. It will not give us any error. So this was about two that what you call methods, that is append and insert. Now there is you have the difference also you can find, that is using append only at the end of the list it is added, but insert we can use to add at any position. Now another thing is these cannot be applied on tuples. So for example, if we have a tuple t1 of 10, 20, 30, I cannot do t1 dot insert or append 40. Now let me run this program. You can find that there will be an error known as attribute error. Why? Because tuples are immutable. Once created, tuples cannot change. So I cannot change any value inside the tuple, or I cannot even update a value, or I cannot add a value inside the tuple. So for tuples, insert append will not work because they are immutable. But whereas lists, they are mutable. So insert, and we are having the methods as insert and append. Now suppose if I have to change the value, let me display this. Now I'm having a tuple 10, 20 and 30. Now the second element value I want to change, instead of 20 I want to make it as 50. So we can do it using indexing. So L of 1, let me assign a value as 50. You can see that we can also update the values or the elements. So now earlier it was 20, now the element has become as 50. So we can also update the values. Now there are several other methods also, what do we call we are inserting. We will also be able to just a minute, there is a doubt here. Sir, I have a doubt. If we use L instead of read, then immediately after that we use instead of 40, then what will be the output? You can install Python and find out. Okay, you try to install Python and find out. This question is, I mean, you can physically work it out. I will show you here, but there are certain things that L1 dot insert of, let's say, 80 comma 8 comma, what do you say, 40. So it is going to insert at the last position. Now you want to insert at the fourth position, 80. So what will now happen is, this is 0, 10, 1, 2, and this is 3. If you are inserting at fourth position, means you will have 10, 20, 30, 40, and then comma 80. For example, I'll show you L1 dot insert of 4 comma, let's say, 80. And when we insert this, now you can find that after the fourth position 80 is at the fourth position 80 is inserted. Okay, is the doubt cleared? Let us move further. Okay, no problem. Let us move further. Where were we? Control Z, Control Z, Control Z. Okay, we can update the values of the uh, list, but we cannot update the values of the tuples because tuples are immutable. Now, the same way we have other methods also, like we are using append, say, let's say L1 dot append or insert element, some element. The same way we will be able to delete the element also. So for deleting the element, there is a method known as pop, like stacks pop of stack. The same way here also pop method works. Now after popping, we will just try to print the list. So let us execute the statement. Now we had the initially 3 elements, then we use the append, so fourth element is appended. After that we are popping it out. So popping means it will remove the last element, that is, as appends at the end, the same way pop will remove the last element. Though it will return also, which is element which is returned, we can save this element and then print it out, but pop returns the element at the end. Now there is a variant of a pop method, that is, the pop method also takes in an argument, that is the position. For example, suppose if I give a position as 1, and let us look at what happens. Now, if you look at it, initially we had 3 elements, 10, 20, and 30. We have appended at the end 40 element has been appended. Now we are popping out at the position 1. That means we are telling it to remove the element from position 1. So pop is default pop method can be used, that is without passing any arguments, which will remove the element from the end of the list, as well as we can pass the this the position there. So here in this case, when you are passing the position as 1, you can look at that this was the list, and on this list we are saying remove from position 1. So this is 0, this is 1. So the element at position 1 will be removed. So that finally we have the list as 10, 30, and 40. So this is how we will be able to remove the elements. Now there are other methods also, like index and find. So For example, let me show you the find method. Find, let me find the element 20. Let us execute this. This object has no find. Oh, sorry, it is index. For finding the element, it is the index. Index is the method to find the element. So to find any element, let's say 20, if it is present or not, we can use index. Now this index, what it gives is, it will return us the index or the place at which, or the position where element 20 is, is present. For example, I can use, let me say I equal to index, and then let me print the value of I. So now if we run, we will get the result as 1, because the element 20 is present at index 1. So this index method will return us the index. Now suppose if the element is not present, now what we have is, we get an error saying 40 is not present in the list. We will not get the we will not get the result as -1 in other programming languages. For example, we had an index of method in JavaScript, and other languages also, and strings in Java. We have a method index of, which returns -1 if the element is not found. But here it will not return -1, but it will raise an exception. Now, apart from pop method, we also have a remove method. So the difference between remove and pop method is, for a pop method, what we were doing is, let's say L1 pop, and within the, I mean, obviously default was there, which will remove the last element, but we were passing the position, let's say 1, position 1, and this pops up this element by position. Now we also have a method known as remove. The difference is that pop method will remove the element or delete the element from the list using the position, but whereas the the remove method will remove the element or delete the element using its value. For example, instead of passing I or 1 as the position, I can pass 20, the element itself. So when we execute this, what happens is, it is not the 20 is not the position I'm passing in remove. 20 is the element itself I'm passing in the remove method. So for deleting elements from the list, we can use remove as well as pop methods. Now there are other things also. I can use other methods also. Suppose if I use reverse, I mean, obviously will not pass any arguments. Now you can find that the entire array will be entire list will be reversed. We also have a method sort, which performs the sorting. Now this sort method, obviously it is already sorted. So let us change the value as uh, let's say 52 comma say 15 comma 7 comma 30. Let us execute this. You can find that this list is being now sorted in ascending order. Now, the list can also be sorted in descending order. What we need to do is, we need to provide a parameter that is, we need to provide the sort. I mean, in the sort function itself, we need to use the same function, but we need to provide reverse as true. So for example, sort this sort is trying to sort in the ascending order. What we will do is we will create L1 dot sort. We will have another statement, reverse equal to, let's say, true. And let us execute the statement. You can find that. Sorry, let me print this first. Again, so we are have printing the original list. We are sorting the list. We are printing the sorted list. We are sorting the list in reverse order, that is descending order, and then again printing the list. So let us compute this. So you can find that this is the original list. We have used just a default sort method which sorts in ascending order. We have used reverse as true, which inside the same sort method as an argument, it will sort in descending order. So this is how we will be able to have, use different okay. So this is how what you can do it in different different methods you can use in the list object. Now there is a method known as clear. So if I use L1 dot clear, it will, and then let me print the list. So it will remove all the elements from the, or delete all the elements from the list. So these are the different methods that can be used on list. Actually, list is a very powerful data object or data structures in Python. Now let us move to sets. Sets is also a collection of type, but it is not in sequence, or it is not an ordered collection. It is not a sequenced ordered collection. It is an unordered collection, and there is no indexing also. Like we cannot use how we were using L1 of 1 or L1 of what you call 2 or 3 or length, so and so. Now let us for our purpose, let me create a set S1, and set uses curly brackets. Set uses curly brackets. Set uses curly brackets. So this way we will be able to uh, okay, just a minute here. Sets also uses curly brackets. So now suppose what I can do is I can directly create a set using curly brackets, and I can have different values. And let me just print the value of S1. You can find that sets is denoted by a curly brackets. Now here you will observe that in list and tuples what we were doing is, uh, since it was ordered sequence, the way we were given the element, the same way the elements was displayed or stored, actually it is stored. But sets, it will not store in the way we try to append, in the way we try to have the elements. It will get stored the way decided by the Python. So sets are unordered. That is what we say. It's a collection, means a group of items are in same way, but it is unordered. So when we are having this S1 set, we are giving the values 10, 20, 30, and 40. But when we print it, what is happening? It's coming in a different way. So that is what, since the sets are unordered, we will not be able to use indexing on sets. So I cannot use S of 1, set S1 of 1. I'll get an error because the indexing cannot be used on sets because the order itself is not decided. So if I say 1, we not know now it is 40, 20, and 30, and so and so. But some systems it might be, the order might be different. So sets are unordered collection. So indexing cannot be used on sets. But sets, there is a property in sets which says that it contains unique elements. So in this set, if I have 10, 20, 30, and 40, and then I can use, suppose if I again provide 20 as the element and run the program, you can find that even though in the set I have provided a duplicate element, that is 20 over here and 20 over here, it is not stored. It is not stored. Only one value of the element is stored. Only one value of the element is stored. That is not stored. Now the next thing with respect to sets is set also has a length function. Let us use len function on sets. We will get the value as 4, even though we are passing 5 elements here because duplicates are removed. That is why we are getting the that is why we are getting the even though they are duplicate elements, but duplicates are removed. So that is why we are having only 4 elements in the set. Membership operator can also be used on set. For example, I can say 30 in S1, which is true. 30, which is true. I mean, that is 30 value is present in set S1. And even identity operators works, but there is no such use of identity operators in sets. Now sets, we can add the element also. For example, let us over here, let us have print s1, then print let us perform some operations. For example, s1 dot, let's say, append. Because they are mutable, we can append, let us say, a value 70, and then again print s1. No, sorry, it's not append. Append was for list. The method over here is add. In sets, the method is add. So once we add 70, you can find that. Obviously, it contained the duplicate element, but that duplicate element is removed, and then a new element 70 is added. Now suppose if I add 70, and if I add an element which is already there in the set, that is, let's say, 40, and then again let me try to print, we get the result as that the 40 will not again be added to the set because the 40 element is already present. When 40 element is present, because 40 element is already present, the 40 will not be added again. So this is we can add elements to the set. As we can add, we can also remove elements from the set also. For example, we can use the remove keyword and then pass the item. That is, let us remove 40 from the set. So when we do this, you can find that we had in the set 70 is appended to this set, and in the next statement we are trying to remove for element 40. So 40 element gets removed from the set. Then we also do have a method known as pop for sets. Pop will remove the last element which is added. So it is not the last element from the end of the set. So 30 is not popped. Now we have added 70 over here. So 70 was added, and now we have 30. So it's the last element 30s, but pop is not returning 30. It will return the last element. Now let us look at what happens if we use pop of 2. You can find there will be an error. So pop of the position, passing the position, can only be used in list, not in sets. Sets, only a default method of pop will work. Then obviously sets also has a method clear. So also has a method clear. So once we do clearing the set, all the elements of set will be deleted or removed. Then we can perform actually some of the set operations also using sets, which we cannot do it in list or tuples. For example, let us assume that we have set S1 as 10, 20, 30, and there is another set S2 as, let's say, 20, 40, and comma, let's say 50. Let's say 50, comma, again 30 also. Let us say 30 also. Now we can perform some of the set operation, that is, we can perform the intersection operation, union operation. So we can use, let's say, print S1 dot intersection S2. Now it works the same as mathematical set operations. That is, intersection means the common elements. So 10, 20, and 30 are the common elements in both the sets. So 10, 20, and 30 are, what do you call? Intersection is performed and we get the result as 20, 30. We can have union also. So union works the same way. All the elements in set 1 as well as set 2 will be combinedly retrieved as union. You can have difference also. Let's say S1 difference S2, that is S1 minus S2. So if you take the difference, what happens is these are the two common elements, that is 20 and 30. So difference is only 10. So there is only 10 element which is left out. So 10 is present. You can do it the other way. S2 difference of S1, which gives us the result as 40 and 50, because again 20 and 30 are the two, this one. So 40 and 50 is returned. Now this way there are other functions also with respect to set, that is superset or is subset or is disjoint set. So this is the set operations that can be applied on sets. The next thing what we have is the what do we call here, what we have is dictionaries. That is the data structures that we have to look into it. Now dictionaries are also unordered because indexing is not done using numbers, but we can retrieve the values using key pair, key and value pair. So we cannot directly say that indexing is not there, but they are unordered. Dictionaries are also unordered, but we can index it not using numbers like 0, 1, 2, 3, but we can index it using key value pairs. Now dictionaries also use what do we call the curly brackets for what for storing the elements. So let us try to create a dictionary. Let's say D1 as a dictionary with using curly brackets. Now I will say let us say that it is CSEA as a key, and value has to be separated by a colon operator. So CSC A colon. Let me give the what do you call some key to it. Let's say 733, comma. So this becomes a an element. So every element in a dictionary will be a key value pair. CSEA 733. Let's say the CSE itself. Second value, let me say ECE colon. Let me have the value as 735, I think. Comma. Let's say what do you call ID colon. It is 7. I don't know, 737 maybe. This is how we will be creating a dictionary. So let us now print the dictionary D1. So remember that even dictionary, the elements are separated by what do you call a comma, as in the other cases. But each element of a dictionary will have a key and value pair. Now, key can be in numbers or even it can be strings, doesn't matter. Values can also be numbers or strings. But keys can be numbers and strings, but keys cannot be list or tuples. But whereas values can be list and tuples also. So for example, if I say CSE is there 7033 and EC, instead of EC, let me say mechanical. Let us say that it's a mechanical department. So when we say mechanical department, now where were you? Sorry. Okay. Now assume that mechanical department also has mechanical, as I think the 736 code is 760 uh, 736. Mechanical also has production also. So what we will do is we will can use a list here 736 and I don't know production. So let us use 738. So what we will do is we are doing here is this CSE key has only one value. This IT key also has only one value. But whereas the mechanical key over here has two values, and these two values we could not have just given comma and comma. We have to create a list here. So the values can also be list. Values can also be list. So that now let us execute this program. You can find that we get the pairs of key and values there without any error. Then the next thing is, now since we cannot indexes using numbers. For example, if I want to retrieve the second element, so d of 1, that is I want to retrieve this element, d of 1, if I use it, I'll be getting an error. There is no indexing with respect to numbers, but we have indexing with respect to keys. So for example, second element if I have to retrieve, I have to provide its key. That is, its key is mechanical in quotes. So I can say mechanical. Now once I retrieve it, I'll be getting the value of the key that is present in the element. So I cannot retrieve directly the element using the indexes. I have to use keys to retrieve the element. The same way, suppose if I provide CSE over here as the key, I will have to I'll be getting the value of that element. Now remember, I'm using quotes here because the key itself is a quote. I can have other keys also instead of quotes. For example, let me do it this way. Let me say 737 and provide IT in quotes the opposite way. So now the key is 737 and value is IT. Now when we don't execute this, we don't get any error. Now here to retrieve, I cannot provide IT. Because IT is a key. IT is a value. So I cannot provide value in the key. What I need to do is I have to provide the 737, that is the key. Now I'm not putting 737 in quotes because 737 is a number. It's not a string here. So when I do that, I'll get the value of the, what do you call, value of the element there. So this is how dictionaries are. This is how the elements of the dictionaries can be retrieved. Next thing is dictionaries also have a length as the function. We can use let's say length of D1, that is the dictionary. It will return us the number of elements, that is 3 in this case. So this is one element key value pair, this is second element key value pair, this is third element key value pair. It's going to return me D1, the length of D1, that is 3. Same way we have a membership operator, but here the membership operator, for example, I cannot use just like CSE in obviously I cannot use CSE colon 733 in what you call D1. This will give us an error. This will give an error. Here, instead of providing the element, this is the entire element. Instead of providing the element, the operator or the membership operators only works on keys. So I have to provide CSE. That is CSE in D1. That is the key CSE string is, what do we call, present in the dictionary. So it's return me true. Now I cannot say 733 in D1. It will say false. Why? Because 733 is not a key. It's a value for that key. So only keys can be used for membership operators in dictionaries. Then we can, what do we call, add in the dictionary, as well as we can remove the elements from the dictionary. For example, to add an element in the dictionary, what we will do is we can simply use D1 of, let me use a key as let's say ECE. This is the key and I want to have the value as 735. Then let me again print the dictionary D1. When we execute the statement, you can find that here this is the original dictionary, and then this EC as the key, because we used EC as an index part, and we assigned the value as 730. Though EC was not there as the key, so new key has been assigned here. New key value pair, a new element has been assigned here. But suppose if I, instead of doing EC, if I just say mechanical, I say MECH, and then provide the value as 735 and run the program, what will happen is, since MECH already is a key, it will update the value. So instead of this list, it has now updated the value with 735. So always remember that if the key is present, then what happens is the value gets updated. Whatever you are assigning, that value gets updated. But if key is not present, a new item will be, or new element will be added to the list. Sorry, added to the dictionary. Now, the next thing is we can pop elements also. For example, I can say D1 dot POP. I can pop the elements also. So sorry, I need to provide the key over here, which element has to be popped. So for example, if I pop mechanical, you can find that. So here default what you call pop method will not work since they are unordered. So that is why I need to provide the key of the element which I am trying to pop or remove. So pop works here, which is used to remove the element through a key. Through a key. Remember, it's always through a key. Now the next thing is what do we have is the other obviously clear as a function which will clear all the values. The next important thing is uh, the methods, like for example items is a method. Now this is for items is a method itself on a dictionary, and this is for dictionary itself. Now what items retrieve is gives us is it will give us a list of key value pairs as tuples. Now remember here, let me first print D1, and then we will use items method on D1. Let me execute this. Now, if you see the D1, this is CSC, first element is CSC colon 733. So CSC is a key and 733 is a value. Now what happens when we use items is that it will return us a list. List always begins with square brackets. So it will return us a list where each, obviously number of elements will be same as the number of key value pairs. So here you have 3 elements. Here also you are going to have 3 elements in the list. But each element will not be like a key colon value. It will be a tuple. You can see parenthesis here. So it will return us a list. Items method will return us a list of elements which are present in the dictionary, and each element will be represented as a tuple. First value of that tuple will be the key, and second value will be the value. So here you can find the second element. It's a tuple which has a key, mechanical, and value as this. So this is how items will work. Now suppose if we need to retrieve all the keys. Have to retrieve all the keys. Now it will return as a list of all the keys. CSC, MEC, and 737 are the keys here. The same way we can use the method values. Values will give us a list of Hello everyone. There was a power cut, so I got disconnected. Uh, can you hear me? Okay, okay. Let us continue. Uh, is my screen shareable now? Okay, 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 okay. I think I have to start again. What am I sharing? Entire screen. Okay. So what we were talking about was the dictionaries here. Is the screen now visible? Okay. Now what we were talking about was the keys method and values method. So keys method is going to give us all the keys as a list, and value method is going to give us all the uh, values method is going to give us all the values within the what do you call within the dictionary as a list. So items is going to give us a list with tuples in key value pair, and keys method is going to give us all the keys as a list, and values method is going to give us all the values in the dictionary as a list. So this is about the dictionary. So we have seen uh, list, tuples, sets, and dictionaries. Um, these are the special kind of structures what we have, a special kind of objects that we have in the what do you call in Python. These are the structures which we would be using, or we would be trying to make use of with respect to the web development part. And lists are very important. List and what do you call dictionaries are very important. Now the next thing which we have is the files, a very small topic. So we are left out with files as one of the topic, and dynamic web page creation as another topic. So today we will just files as very small topic. So let us complete the files topic itself. Now files is nothing but we have to use certain operations, and the result of just a minute. Okay. Uh, Now this file topic why we need files, because there might be some situations where we have to save the data in a file, or there will be situations where we need to retrieve the data from the files. So in such situations, files are used. Now in Python, create reading data from the files or writing data on the files is very easy. Now let me just try to uh, take an example. Let us try to read the data from a file. So what I'll do is I'll just go to the same directory. I'll just try to create a file. Let me say that it is data.txt file, and let us say this is first line and this is second line. Let us have these statements as this is let's say third line. These are the statements. Now let us assume that this is a file, data.txt file already created. Now I have to read this content from this file, data.txt file. So what we can do is we can use file operations. Now first thing is we need to create an object for file. Let me use object as f1. Let's say just say f. Let me say file read as an object, and using the assignment statement we can use a method open, and we need to provide first argument as the file name within quotes. Now my file name was data.txt, what just now what we have seen, and the second argument we need to provide the mode. Now here there are actually 6 modes: read, write, append. Read, write, actually 5 modes: read, write, append, and read, append, and write, append. So that way, but usually what we do is we use only 2 modes, or we usually use only 3 modes, that is read, write, and append. So here we are trying to read, so we will use R as the what do you call what do we say, R as the mode there, reading mode. Now once we have this R, let me just try to use print file read. Now if you see, when we execute this, we don't get the entire content here. We just get an object. We just get an object here, which says mode is read, so and so is the file name. It's a text IO wrapper object. Now to read the contents, what we have to do is we need to use a method as read. So we will use a variable contents, and we will use file read as the object dot read as the method. Now what happens is read will read the entire content of the file. Which file? Using the file read object. File read object has opened the data.txt file in the read mode. So entire content of data.txt file will be read and stored in contents. Now we will try to print the contents. Now we will try to print the contents of the what do you call the data stored in the contents variable. So now you can see that we have the content. Every line is retrieved. That is, the whole content of the file is retrieved and displayed. Now suppose if we have to read a line by line, that also can be done. Or if we have to extract each line at a time, that can also be done. So to do that, what we will use is we will use, let's say, lines we will call as object, and we know that the entire content is in the contents entire data is in contents variable. So we all know that in a file the statements or each line is delimited by by a new line character, is delimited by a new line character. So here what we can do is we can use a split as the function. We can use split as the function, and this split function we will split it using /n as the delimiter. So now when we display lines, the data which is stored in lines, you will find that we get lines as a list where each line is an element. So this is one element, this is another element, and so on and so forth. Now once we have these elements, what we can do is we can use a for loop for L in lines. We can print each element, that is L. So now once we do it, you will be able to find that each element is now retrieved line by line. So first time when the println statement is used, it will be what you call it will be giving the result as the first line, the content of the first line, then second line, subsequently third line. So this is how we will be reading from the file. The same way we can write to the file. For example, let me say data out as the file data out.txt, and the object we will have is w, and instead of read method, we will say write method. So let us call this object as file write, and what we will do is we will say file write is a method. Now here write what I will do is I'll start passing. Let me say line 1, and then I can also again use line 2, then I can use line 3 or line 4 to write on the file. And remember always, even in a file read and file write, remember always to use the close method to close the file at the end of each operation. Now I don't have any file named as data.out.txt. So let us run this program. If there is no file, that file will be created. If the file is created, since we are using write mode, it will be overwritten. So you can find that line 1 is written, then line 2 on the same line it's coming. This is because we have not provided any new line character. So if we provide a new line character here, in this case, we will be getting getting the different lines. So now we can see that it's the output is on different lines. So this is how we are doing it in terms of write. Suppose if we use append, and suppose if we had write itself, and this file was already having 4 lines written, and now if I say line 5, line 6, and execute it, what happens is this file will be overwritten with the other values, that is line 5, line 6, 3 and 4, which is now present as this line. So if it is write mode, it will be overwritten. So let me just change this back to line 1 and 2 and then execute it. So you can find that it has line 1, 2, 3, 4 written. Instead of w method, I'll use append method, and this append method we will have let us append line 5 and line 6 line. Let's append only 2 lines, and just let me run this program. You can find that in the route I'm the data out file, the existing file. This was the previous data since we have used append. So this was the previous data. Since we have used append, other 2 lines are also appended to the existing file. So a file can be opened in read mode, write mode, as well as append mode. Now why we have covered files? Because we will be using these files, or the reading and writing data onto the files in the next topic, that is dynamic web creation or creating dynamic web pages. So this was all about the basics of Python, or whatever we have in the syllabus for Python. Only topic that is left out as part of the 3rd unit is web scrapping. Sorry, not scrapping. Creating dynamic web pages. So creating dynamic web pages, it's a topic. We'll just try to look at it, or try to complete it in the in next class, because we have to talk about CGI programming, and we need to practically look at how and where to place the files in a web server, and which web server to use and all those things will take a lot of time. So let us continue the creation of dynamic web pages in Python in tomorrow's class. So for now, let us end this class, uh, and then tomorrow we will take up the what you call creating dynamic web pages. Now, to create dynamic web pages, we need, we have to follow the same procedure of how, where to place files in web server and all, like we did it in Java servlets or Java server pages. So I'm not having power over here. There's a power cut. So anytime, I may be disconnected. So that is the reason I don't want to continue further with what you call creating dynamic web pages. So we will continue in the next class. We will continue the dynamic web pages in the next class. I thought of completing it today, but I may not do it. So if you in tomorrow's class we will continue with the dynamic web pages, and hopefully we will complete in tomorrow's session. And then we will start with the fifth unit. Fifth unit is not long. We will be able to complete in 3 days. Now, if you have any questions, you can go. There is a internal marks. Internal marks. Where are internal marks? Yes. I told you I have the internal marks, but not papers. But let me search whether I have internal marks here or not. I forgot to what do you call find out the internal. Look for the internal marks. Though at it's there on my system in the at college, but let me find out whether it's there with me over here or not. So I'll just find out. I have not searched for the internal marks. Any other technical question as such, or can we stop the class? Okay, no problem. If you don't have any doubts, then thank you very much. We will continue tomorrow at 11 a.m. or 11 o'clock.